All right, let's talk about calculate probability of OR event and AND event. So the first question is, suppose we got two events. Probability A has 0.3, A has probability of 0.3, B has probability of 0.5, and these two are mutually exclusive. Mutually exclusive means they are not going to happen at the same time. So that means A and B won't happen at the same time. When you look at a Venn diagram, it means like this is where A is, and this is where B is. And A has 0.3, like 30%. B has 0.5, 50%. But they're mutually exclusive. They're separate. Okay, so in this case, do you remember if they are mutually exclusive, what is the probability of A and B? What is the probability of A and B?
0.
It's 0. Okay. So if you are calculating probability A or B, which is, I think this is the notation, A or B. What is this?
I don't know.
You don't remember?
Or B?
A or B. So A happen 30% of time. B happen 50% of time.
So 80% of the time?
Right. A or B is 80% of time. You would add these two. So it's 0.3 plus 0.5. And they're totally separate. They're disjoint. So you don't have to worry about them happen at the same time. That means they're separate events. All you have to do is add it together. That's 80%, right? Now the other one is when they are independent. What do we mean by independent? Independent says that probably C and probably D, that independent means the inside C or D or not inside C or D has no effect. So probability C is 40% of time, so which means saying that you get 1, 2, 3, 4, 5, 6, 7. I'm trying to make it 10 to illustrate the 40% of time, because that's the key thing. So probability C, it is 0.4. That also means 4 out of 10. Okay, so C has 4 out of 10. That's C. This is C. Okay, now probability D, it is 0.8, which is the same as 8 out of 10. So C and D are independent, so they won't affect each other. So I'm going to draw perpendicular line to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. It's independent from C, so we're gonna draw separate 10 proportions. And the D occupy 8 of it. Well, this is still C. Like C occupy 4 out of 10 vertically, and then D occupy 8 out of 10, which is 8 of the horizontal line. Okay, this is leaving 2. There's 8 of these this way. So slant it that way. That's what I mean by 8 out of 10 for D. Now, the question is, what is the probability for C and D? like the one that belongs to C and belongs to D. You see how large it is?
4 times 8
And out of how many?
out of 100.
Out of 100. Which essentially is 0.32, right?
Mm-hmm.
And that when two events are independent, probability C and D, it is equal to probability C times probability D,
Mm-hmm.
which is also 0.4 times 0.8, and that's 0.32. I'm trying to use this cross graph to show that this is actually 32 pieces, but the total of the whole thing, and this is actually the total of the whole thing is actually 4 times 8 is 32 pieces, but this whole thing has 100 pieces, so 32 out of 100.32. That's by looking at the area.
Mm-hmm.
But you can also simply do multiplication. In probability theory, we call this multiplication rule. You multiply probability of two independent events, that will let you calculate probability of the n event. And then that eventually become a little formula for independent events. But this can actually show using the little area calculation. Mm-hmm. And that we have a second question, which is a probability for C or D. The notation is actually probability C or D. So, do you know how to do this calculation? The part that's in C or that's in D?
No.
No. So you see how many pieces belongs to C?
Mm-hmm.
Which is about 40 pieces out of 100 pieces. What portion does belong to D?
80.
80. So essentially, if you add these, 0.4 plus 0.8 minus which part?
0.32.
Why do you minus that part?
Because that is the part where both C and D are.
Right. So if you add this piece with this piece, you're adding this piece twice.
Mm-hmm.
And that's why we have to subtract that part. So eventually, the OR event has 1.2 minus 0.32. That gives us borrow 1, 11 minus 3 is 8. So it's 0.88.
Mm-hmm.
That's it.